Hello and welcome to Elektor Engineering Insights number 46. I'm Brian Tristan Williams, and today we're joined by the incredibly talented Patrick Hood-Daniel, the creator of BuildYourCNC. Patrick's journey from his early days programming on a Tandy TRS-80 to his expertise in CNC machines and now STM32 microcontrollers, it's fascinating and inspiring. So we'll take a look at his work and his passion for teaching and how he's simplifying this technology for makers and engineers everywhere. So stick around, it's going to be a great show. And Patrick, thank you for joining us.
Oh, you're very welcome, and I'm honored to be a part of your show. Thank you so much for having me.
Great, thank you. We've got a tremendous overlap between your audience and our audience, and which brings me to greet the chat room from people all over the world. I've seen people here from the USA, from the Netherlands, from Germany, and we had quite a bit of people waiting to get on with us. So I will mention that we have a great giveaway today. It's this book. 5 lucky viewers will get a copy of it. It's called Nuclear Board Programming with the STM32 Cube IDE. It's a hands-on guide with over 50 tested projects for the STM32 Nucleo L476RG. So it covers everything from basic LED projects, your usual Hello World, to advanced features like I2C, SPI, and DMA. So to enter, you just visit this link. I will come back to it later, as we always do, but it's elektormagazine.com/elector-engineering-insights giveaway. And you have to enter a code word to enter the competition, which I will give away around halfway through the show. So stay tuned and good luck if you are entering the competition. Now, let's head over to Patrick here, who's just next to me, one way or another. Patrick, so you began programming very early on a TRS-80, as I understand it, and then you became a CNC innovator and an educator. So what was the moment that made you realize you wanted to combine your passion for electronics and teaching to help other makers?
Well, that's actually kind of a long story. The starting with the TRS-80 was when I was actually about 7 or 8 years old. I was pretty young. I'm 56 now. And that's when I actually started programming. I actually started programming computers. I surpassed my father. He asked me to write programs for him on the TRS-80 Model 1, Level 1, which was a 4K computer, 4K of RAM. I think any microcontroller that I use now is probably more than that.
Yeah.
And then I upgraded to the Model 3, then the Model 4, then the IBM, and I got into programming, but then I stopped that. I decided to go into architecture and urban design. So I got my BArch and then my MUD degree at UC Berkeley, and went on to do urban design for the city of Houston and also for the city of Miami. And at the place where I was with urban design, I was a little bit frustrated with the work that I was doing because in Houston, there's a lack of zoning. So I needed something else. And I went back to my first love of programming and electronics. Actually, I don't know why I didn't get an engineering degree, to be honest with you. I should have done that. But I still love the architecture side. So I got into, I had this like burning desire to get into robotics and to try to see if I could achieve bipedal balance on point feet. And that is like probably one of the hardest things that I could think of doing with robotics. And just now they're able to do it in the past not too many years, because Boston Dynamics created Atlas, and they were able to do it. And those feet are very small, in relation to their bodies. So that's why I got into electronics. And also that's why I got into CNC too. And I wanted to create a CNC router machine that could create parts and mechanical parts, structural parts for robotics. And it just so happened that I got in pretty early in the DIY side of things, where there was another person that was doing this. His name was Joe, and he has the Joe CNC. And I tried looking at that design, and I wanted to make something very similar, but I wanted it to work with what I had on hand, some bearings, some skate bearings, and riding along a aluminum tracks. And then I found out, well, I didn't start with that. I started with what everybody starts with is the round rails, and I was doing it in a way that was causing the round rails to sort of bend, and then it would spring back into the middle of the axis. So I tried various things. So sort of another idea was born from that, which was the angled bearing, angled angles, and then putting wood between it, so there wouldn't be any sort of compression between it. And that worked out to be a really good system. So at that point, I wanted to show off my design, so I went to all the maker fairs, like the Austin Maker Faire, the first one that was actually created, I think, in Austin, but the first one was San Mateo, but then they did it in Austin, which was around 2007. So that's when I got started with the CNC stuff. But it was all for sort of a means to an end for, robotics.
Wow. And I don't want to go off on too much of a tangent, but this is one of my interests.
Yeah, sure.
TRS-80, you said it had 4K of RAM. Did it have video RAM as well?
I don't actually know, but I do know one thing. I expanded to 16K, and I never thought I would get to that, to be able to use all of that amazing RAM.
Yeah.
It was like, wow, 16K, what am I going to do with all of that? I was like, I was getting to the limits though, 4K. So, but 16K, just like today, like 4 terabytes now is not enough for a lot of things.
Yeah, exactly. I asked because RAM was expensive in those days. I'm imagining about 78. And at that time, Texas Instruments put out their first home computer. I have a later version there, but regardless, it only had 256 bytes of CPU RAM. And the rest it had to do by negotiating with the video chip, which had 16K of slower, cheaper RAM. So that's the rabbit hole I wanted to go down. I was curious about your TRS-80. And you started beating the pants off your father in terms of programming.
I did, yeah. And it's interesting, the microcontrollers that we use today are essentially those computers then. We're doing the same thing. We're kind of starting over, but in sort of a little tiny miniature size instead of that huge big box of computer. Yeah. But yeah, and my father needed some programs, and he bought the computer. He was in an electronics course, so that's why he got the computer in the first place. And it was just a perfect time, when I was young. I was very impressionable. I was learning a lot. That's all I really cared about was computer. My grades suffered because of my involvement with computers, so probably for a good reason. And I'm glad I focused on computers rather than my schooling.
Yeah, I'm with you there. I would be working out how to count in binary instead of doing my math in math class.
Right.
But one thing I envy about you is, as I always say on this show, I'm okay with electronics, especially digital electronics. I can program an assembly down. I can decode binary instructions, but I can't make things move. I'm not a mechanical guy. So you try to bridge the two worlds, mechanical stuff and electronic stuff. And how did you first do that?
Well, actually, in architecture, they teach you a lot about that stuff, which is kind of interesting. You have to understand statics, mechanical systems. People don't really realize how the breadth of architecture, but we actually do. I remember some studios that I had to create mechanical systems that things that move. So sort of ephemeral dwellings that would it moves in certain ways, and that was sort of the challenge. And that's kind of taught, but I learned pretty much everything that I know from the internet. I think they call that an autodidact. I think I'm one of those. So I'll put myself in that category. But the difference between me learning sort of those mechanical systems is what I'm trying to do is actually learn, but use the internet as my sort of notebook, or use video as my notebook. So as I'm learning things, I'm putting everything on video, everything. In fact,
Yeah.
today, in the past several months or a couple months, I've been live streaming every single day. That's forcing me to do work, first of all, but it's also a way for me to learn new things. And now I'm doing it not in a vacuum. I'm doing it with others around me in the chat, and whoever wants to come in. So that keeps it very, very real.
Yeah.
But pretty much what I like to do is I like to just put everything online, and whatever you see, all the tutorial series that I have um, in my channel is all from me just learning this stuff and trying to convey it in a way that I would understand from a complete novice. Like I said, I don't have an engineering degree. So that's sort of what I've been doing. But I've been doing it in a way that it's a little bit different than most DIYers out there. And I'm starting with the single chip rather than starting with a platform like Arduino, or like you were showing the nuclear board. That's an incredible board. It's a great board. But I personally like to start with the chip, right down from the chip, and then add whatever I need to the chip, like passives and other ICs and things like that. If I need them, I'll add them to the circuit. So I like to start from the bottom up approach, not
Yeah.
the sort of the top down approach.
Yeah, I can relate 100% because I got my first computer in 1984 and it came with a manual and it taught you this basic programming language. And that was top-down learning. That was an arbitrary language that they stuck in the machine. And there was a lot of rivalry between different brands of computers, everyone thinking theirs was the best. And then only in the 90s did I start bottoms-up learning from first principles, assembly and microcontrollers. And that's when I realized how much in common these different computers had, although they were different on the outside with their operating systems and that. And since then, I've been a big fan of bottom-up, and that expands to different areas of my life. When it comes to cooking, I like first principles. Give me the original ingredients, not a sauce in a bag, you know,
Right,
from the
right.
store. And so I love.
That's a really good analogy, actually. Yeah, I like that.
Yeah.
But we have such a great amount of information out there on the internet now that allows us to do all of this kind of stuff. Like, you know, there's no reason why you have to start with something top down anymore. You can do anything you want, and the information is out there. And the companies like ST Micro are making the development so easy. You know, like I do get this discussion quite a lot in my live streams and in my comments, where they say that, you know, just doing the bare chip is just so hard. But I think they're caught in the concept of that. It's like they're making it hard in their mind. The programming is the same. The only thing that's really different is one has a bootloader and the other one doesn't. The chip itself can do pretty much the same things. You just have to wire it up. That's all you're really doing. In the case of Arduino, you're adding a shield and then you're wiring stuff up anyway, or you're still wiring from the shield headers. And it's the same thing of, you know, as wiring from the pins of the microcontroller. It's the same thing. So that's what I love about today. We have all of that information, and nothing is sort of hidden behind any barriers. And the companies are doing a great job getting that information out there. But I do have to say one thing. Doing it from the bottom up, you do have to sort of start digging into the data sheets. And that's one little thing that might cause a little bit of pain, but it probably is a good idea to do that anyway.
Yeah, I loved data sheets. In around 2000, I would go to the print shop and print. The chip is only this big, but the manual is this thick for the chip. So I was taken aback a bit because I started when you either ran a computer like a Z80 based board, and then later on with microcontrollers that had built-in flash, but to program the flash, you needed to solder together something from your parallel port and to bit bang the outputs and program the chip. And then I was taken aback when Arduino arrived on the scene, and it was so easy. You could just plug it in and type in a little code, and there you had your LED flashing. And I was like, I had to work hard for this stuff. But then I realized it wasn't a complete loss, because I noticed visiting forums, people only understood that IDE way of doing things. They didn't realize that on that Atmel chip at the time, the 328, there is actually assembly code running there, and you can program it with bare metal, and people were having real trouble with that, as you said.
Yeah, there's another YouTuber out there. His name is Ben Eater. Have you heard of him?
Oh yeah, definitely.
Yeah, I don't know if you've had him. You should get him on your show. But he showed the entire BASIC language, and he programmed the BASIC. He showed the I think the code. It was the assembler code for BASIC.
Yeah,
for the actual language. That's what I started out with, was BASIC, and I actually did a lot of programs for even the commercial side in BASIC.
Yeah. Well, you're supposed to be the guest, so I shouldn't be talking too much, but I can't help myself. The computer behind me that I told you about, because it only had 256 bytes of CPU RAM, the BASIC was not programmed in assembly. The BASIC was on 8-bit serial ROM chips, which you had to read 1 byte at a time, and they came through sequentially. Oh, wow. But if you wanted to change addresses, you would then send the addresses 1 byte at a time, and it would acknowledge. So that made the computer doubly slow, because the BASIC was programmed in another program, which the assembly monitor would have to. It was crazy, and it was probably the slowest BASIC on the market in around 1984. Including according to magazines like Compute. They did benchmarks on array sorting, and this came way behind, but still I loved it. And later on I learned assembly. I just want to hop over to the chat and just show you all the countries from around the world. Norbert from Hungary. Nice. We've got Germany, we've got the Netherlands, we've got LA, which could mean Louisiana, USA, or could mean Los Angeles. I'm guessing Los Angeles, meaning it's
very early there right now.
Yeah, 7:18 a.m. there. We've got Chase's Crust saying hi.
Hello.
And Spain, Norway, Canada. So it's great to say hi to everyone, but I hope you're going to be engaged and give some great chat questions while we're on the show. So now, having a look at your body of work, I think it was 2009, you co-authored a book about CNC, and 2009 you were still using parallel ports, and I once put together a circuit in the 90s. I had no idea how it worked, but it was analog switching matrix chips, and then I would plug that into my parallel port, and using the electronics magazine, it was an American one, Everyday I don't know, Practical Electronics or something, I could get that thing to switch switches from basic or assembly. But by the time we got to about 98, 99, Windows had taken away that direct access to the port, which was a shame. And you needed drivers and that sort of thing. But looking at your co-authored book, by 2009, you were still using the parallel port and not dedicated microcontroller circuits. So how come that LPT1 lasted so long in the CNC era?
Yeah, that's actually kind of a pain point. When I started out, it was parallel port all the way, and the parallel port works like a GPIO, the general purpose input output, for like a microcontroller. It's like the Intel's GPI port. They allow you a few pins to play with on their microprocessor. So that was a really nice way of communicating with CNC, because you had parallel processing, or you were able to play with any of those pins individually rather than in a serial fashion. So you could have all of your axes on a different pin. So you have your x-axis pulse and you have your x-axis direction, and that's how things work with CNC. You have the pulse causing a stepper motor to turn, and stepper motors use steps to go all the way around. So the pulses from the parallel port directly from the pin go into the driver of the stepper motor, and then it causes the stepper motor to turn. So you had you don't have all 25 pins. You had maybe, I think, 18 or 17 pins of those were available to you The rest were just ground. And so you had those available pins, so you could do 5, maybe even 6 axes if you wanted to, just from the parallel port, pumping out those pulses, and the high or low for direction, high being one direction, low being the other direction. So, and I don't think they've really gotten rid of them. They've gotten rid of them on the backs of the computer. They might still be on some of the motherboards if people still want to use them, but you're starting to see those disappear, I think, too, especially with the mini ITX size motherboards. So yeah, they're getting away from it. And Windows, they're putting that layer on top of what you can access. So, you know, for security reasons, obviously. Yeah. So now you have to deal with, you know, drivers and things like that. I don't know with Windows 11 if there still is access. I'm not actually sure, because I've been out of using Parallel for such a long time that, you know, I haven't steered any of my customers or anybody that watches me towards the Parallel port anymore. Now it's either Ethernet or USB. And that's actually a kind of a lively discussion all in its own, because there's just like politics, everything is divided. And a lot of people don't like the USB. And I've done a lot of programming microcontrollers and actually creating my own CNC controller using a microcontroller and processing the G code and parsing the G code into those step pulses and things like that. So I know how it works, but I don't have a full grasp on it. But I'm thinking that that's sort of the way it works. Higher level commands go on the USB, and then it's parsed on the microcontroller, because the microcontroller does that very, very well.
Yeah. I think USB, it also, being first principles kind of guy, I think USB has a lot of layers and abstractions, which can be a bit of a turnoff. But then Ethernet is not simple either. Really,
right.
It's been around a lot longer. And then you moved from parallel ports to microcontroller boards. Did you go straight for STM32, or did you have some steps up?
Well, the route that I took with the CNC machine side and doing the parallel port stuff is sort of one side of things. That was just on the CNC endeavors that I had. The microcontroller stuff was actually I was focusing on that just in terms of controlling robotics, and not in the CNC robotics side, but bipedal locomotion, balancing, those kinds of things. And I have a strong interest in neural nets, and that's one of the things that I got into when I was getting into electronics. I was also learning about neural nets and artificial neural nets, and because I would need to understand those kinds of things to get into balancing type of algorithms, or at least black box type of algorithms. So yeah, that's how I got into, actually I didn't get into STM32. I first got into the AVR and the Atmega stuff. And I created a set of tutorials back in 2010, a very large set of tutorials that's where I was starting to get into microcontrollers. And that's where I was learning microcontrollers. And that's where a lot of people, you'll see if you go to my not my website, but my YouTube channel, go back to the AVR series, you'll see that that was a very popular series, and people still come back at this time talking about the characters that I created during that series, which I try to teach or also learn myself, because that's why I was making the videos. Like there's little tiny people inside of the microcontroller controlling a huge switchboard, because the switchboard is just switches on and off. And hold on one second. There's my 30 minutes.
Yeah, you get 30 minutes on that camera timer.
Right.
But luckily you're not using the microphone through the camera.
That's right. So making sure my microphone thing is off. So when I was explaining that, there's like a little person, controlling a big switchboard. The switchboard are the large panels of switches are the registers, and there's a lot of those. And then each individual switch would be the bits inside of the register. So I was teaching it sort of in that way, so people could really understand. So I had characters like Mr. LCD, and that was the one that was controlling the 8 data lines of the LCD, and then you have the read write and the enable, and so they were flicking off and on those little switches. So I was trying to explain it in those sort of terms, and I got a lot of people into engineering jobs because of that, and they've been thanking me. Even to this day, they tell me about those stories, which is really, really heartwarming and also very humbling at the same time, because I just really think that it's a remarkable thing for a person that is learning it can still actually have that kind of effect on people, and I'm very proud of that. So then I got into the STM32 because I wanted something a little bit more powerful than the AVR series could deliver, but not just more powerful, because they were actually creating ARM architecture chips. The STM32 was just so cheap. Before COVID, they were very, very inexpensive. Then obviously COVID happened and you couldn't buy anything after that, but and now you can, so everything's back to normal. But before that, I wanted to step up. I was very afraid of the step going from AVR 8-bit to a 32-bit system, and just not knowing like what I was going to get into, and then looking at the reference manual, which was 300 or 400 pages long. I printed that thing out.
Yeah.
Just like you were telling me, I think before this live stream, I printed it out, and I was actually reading that while I was working as an urban designer, or like when I was on the bus going back and forth from work. So yeah, and it was scary, but now that I got into it, it really isn't as bad as I thought it was. So I encourage anybody to get into like bare chip, bottom up type of development, and just learn it. Whatever is online, just learn it. It's a great system. So I wanted to get into the ARM architecture, and then once I'm there, I'm essentially set, because if you understand the ARM architecture, or you understand at least the way to program in that environment, and generally I do register level programming. I don't do the HAL stuff or CubeMX, but a lot of people, that's another sort of place of contention. A lot of people say you have to do it with the CubeMX. Don't do it anywhere else. But I personally like the register level. I like to understand what's going on. I like to see what I'm changing, the bits that I'm changing, and doing it in relationship to the data sheet and the reference manual. So that's why I got into the STM32. Long story, but that's how I got into it, and that's why I really, really love this environment.
Yeah, long story, but a great story. And call me old school, but I do feel like a data sheet just feels more real when you have it on paper, and you could feel the weight of it. I mean, the RP2040 used in the original Raspberry Pi Pico, it's a chip that's smaller than my pinky nail, but the data sheet for it is 597 pages long, if you really want to take a deep dive into that.
Yeah, and just a quick note about data sheets and reference manuals. When you are controlling a microcontroller, it is a microcontroller. You're not really, when you're thinking about doing something specific in a microcontroller, like when you're enabling a feature of a microcontroller, let's say I want to enable the ADC. You want to receive analog voltage signal and then have it converted into a digital signal between a number, let's say 0 to 1023. That is a single line of code. You're just enabling that, and then you are checking to make sure it's enabled. So I want people to understand that it really is that easy. It is just you're flicking on a switch, and the ADC is on. You're checking to see if another switch is on to make sure that the ADC is enabled. And then you're doing the same thing to other parts of that feature, like, calibrating the ADC and things like that. So, I just wanted to add that because I think it's important to understand that people really think that you are like you have to be an inventor and you have to be like somebody super smart to do this kind of stuff. And you really don't. You can start at any time and you can do anything. And that is the magic of these things. And speaking of magic, these little tiny things are such magical little devices.
They are. I mean, case in point, the thickness of the manual in something that you could breathe in by accident if you're not careful.
That's true.
And I can relate to that story of you just flip a switch. I mean, when I started learning to program 8051, that's the Intel microcontrollers, I needed to talk to a smart card via serial. And I didn't know how to use a UART or exactly what a UART was, but I knew serial protocol. So I thought, I don't have time to learn this UART stuff. Let me just bit bang in assembly. So I did that. And then when I wasn't on a deadline, I took the time to look at the manual on the UART. And I was like, oh, you mean I just write the byte to the UART and it automatically flips the bits, toggles everything. Wow, okay, that's easy. That's like you say, one lever and you've turned on the ADC.
Yeah, if you're a programmer, if you're assigning a variable, it's all you're doing. You're assigning a different variable, and you're putting your byte into a buffer that is going to be automatically sent.
Yeah.
So it's that easy. Yeah, you're just assigning a variable to or a value to a variable, and you're just assigning a value to a register. It's the same thing. Yeah.
Yeah. Okay, I'm surprised. I'm going to switch to our giveaway again, but let me just bring this up. So Patrick is from BuildYourCNC. There's his website, BuildYourCNC.com. If you scroll right down to the bottom, there's a lot of interesting stuff here, and it's a store. But right down at the bottom, you'll find his socials. And primarily, I've been looking at him on YouTube, so that's in this tab over here. Head over to BuildYourCNC, but it's actually youtube.com/@PatrickHoodDaniel. You can see it there. The resolution is sufficient.
Also, on the chat on the website, you are talking directly to me, not a robot. So when you go into the chat, you get directly connected to me. So just wanted to let you know that.
Great. I think you're busy right now, so I won't bother you in the chat over there.
I'll get that notification anyway.
So as a reminder, our giveaway, we're giving away a nuclear board programming with the STM32 Cube IDE. It's a book by our regular author, Dogan Ibrahim, and a lot of good projects in there, 50 projects. There's that nice ST whiteboard. The chip there is a little bit bigger than a pinky nail, but nonetheless, because we're having Build Your CNC on our show, there's the giveaway page. Let me put that up on screen. I've decided that today's code word will be Build Your CNC. The case really doesn't matter. We'll get your entries and hop on in there, enter the competition, and good luck. We're excited to see how many people enter for that one. Now, you take the chat yourself, so you're very hands-on, and you do this crazy thing of having a live stream every single day at 1 p.m. your time, which is 8 p.m. my time. I try to watch a couple this week, but the kids were not really entertained by your technical stuff, although I was. What's that like? You're putting a lot of, I mean, you've got family and everything, and you're still putting so much time in with the community.
Yeah, until I get burned out. I'll be doing this until I get burned out. No, like I said before, I'm doing this because I'm forcing myself to do this. I'm like, it's easy to sit down, like I have my own business. It's easy to just get relaxed and then just sit down and just lose time doom scrolling or looking at videos. I do look at videos that teach me though, but still, it is easy to fall down that rabbit hole. And instead, I decided I'm going to take a couple hours of my day and I'm going to force myself to go back to what I was doing back in 2009, 2008, 2007, and get back into learning more, getting widening my breadth of information that I can learn. And I've learned that watching my previous videos myself, I'm like, I've lost a lot of that stuff. So I want to get back into it daily. And I also want to do this not in a vacuum, because when I'm making videos by myself, when I'm researching for the video and then I create the video, I'm leaving a lot of stuff out. And that's a big problem, because that right there, a lot of people will start to see problems themselves that they can't solve. So what I do is I make sure everything is out there. If I mess up, everybody's going to see it. Everybody's going to have a criticism about it, because that's what the internet does.
Yeah.
And you have to really have thick skin to do this. That's sort of my burnout thing. But I don't think I'm going to be worrying about that, because so far it's been pretty good. I've had a lot of folks say that you shouldn't put that information online. You should only put the perfect information, so people will learn and I'm not wasting their time. But I don't agree with that. I really agree with putting everything out there, creating and building a community of people that can talk to each other and that can also watch the live streams, ask questions. If I don't know the answer, somebody else may know the answer. And a lot of cases, like in my, I was doing an OLED 128 by 64 little tiny display project, and a lot of stuff was like very, a lot of stuff that I knew very well back in 2010, 2014, 2019. I forgot. So they were reminding me in chat, and I'm like, oh, that sounds like the right thing to do. I remember that I did that back in the day. So let me try that. So it's really cool that I can use the chat. They can use me. They can use each other, and we can do lots of really cool experiments. And I think that's also something that works for live stream, because they want to see, like, it's kind of a cliffhanger. Like, is this thing going to work? So I personally like that as well. I'm sort of an experimentative kind of person. I like trial and error. That's actually how I learned programming in the first place, was trial and error. I learned a lot of what not to do, and I also learned a lot of what to do. So that's I think that's where my live streams are. That's where the benefit comes in to my live streams.
Yeah, well, it's a huge benefit, and I imagine with AI now, you could pump a transcript of all your previous videos into a personal GPT, and you could ask it questions about stuff that you potentially have forgotten about, that either your audience would tell you or the GPT could tell you. That's a bit of a tangent, but are you using much AI to help you lately?
I am, and I love it. But another, I also spoke about this in the last live stream, that I am actually doing these live streams for another reason. It's because I want my kids to be able to have a record of me, and in every aspect, because live streams will give you that. A polished video will not. So a live stream will give, my personality, and later on, in maybe 1, 2, 5, 10 years, there will be the possibility, I say 1 year because I think could be that fast, that you could actually take all of this information about me, my videos, all of my writings, and you could essentially create another sort of an avatar of me, and they could talk to me for the rest of their life if they wanted to, if I've passed on. So AI I do use in my development now, because that makes things so much easier. The entire OLED program, that's the first program that I actually had. Well, it's not the first program. There was a couple other programs that I did, I think, on previous videos, the more polished videos. But in the live stream, I had Claude, which is my preferred AI, create the OLED program, complete with the I2C, which is a communication protocol. The I2C communication, the initialization, it also created all of the characters, the alphabet, the ASCII character sets. Well, some of it.
Yeah.
But it was able to do that from whatever it knew from the internet. It didn't really need anything that I used, but who knows if it trained off of my information. It may have, but I was able to do this in very, very little time. So I'm just prompting it, the AI, and it spits out code, and I am flashing that code directly to my microcontroller, and it works. There was a couple stumbling blocks, but in time, I think that's going to be worked out. But as long as you give enough information to AI, it will provide some amazing information. And I love AI, and I love the aspect that we're able to do this. There is, of course, I get this a lot in my live stream. What is the future of jobs? And I'm not really the right person to answer that question, but that is a kind of a subject that I get, and I do enter a dialogue with the chat about that.
Awesome. And I'm tempted to say something that would take another minute because this is such an interesting conversation, and I feel like we could do 2 hours if we had the time, but I've got to give it over to the audience. Alan Miller says that he finds that there are a lot more tutorials and help available on Linux versus Windows. Yeah, I'm working on a project now, and yes, it's great. I love the open source. I love the simple answers on Linux. And to your point, Patrick, I do these articles and I have failures too. And it's tempting to skip over that and say, no, I just went straight from point A to point B. But the mistakes are valuable as well. Mm-hmm. As a thank you from Hetor, thank you, Patrick, for your AVR and STM32 tutorials. And
you're very welcome.
Question from No Spam. For those using PC platforms, is Linux a better choice? E.g., ability to touch the actual hardware? I can't say I know. I have not done Linux much on PC, except running it in Windows. What about you, Patrick?
I have gotten into Linux on the CNC side. Linux is a great platform. There's a program called Linux CNC. It's EMC, I think it's EMC. It's called, and that is an incredible program. It's an incredible control program for CNC. In the Linux environment, and it has I created a pick and place machine called the Red Frog, and I wrote all of the programming, G-code programming, not traditional programming, but G-code in Linux CNC, and runs that entire machine, including all of the actuation of the vacuum and everything you can think of when it comes to picking and placing and locations, and making sure things are happening correctly. But also, like the G-code, a lot of people don't realize that it's a programming language. You can have loops in there. You can have calls to other functions. You can call to various other files with other functions. So it's pretty wild what you can do with G-code. And G-code, for those of you that don't understand, G-code is the language that moves a robot or a machine, like a CNC machine. So if you decide to cut out a square, you would have probably 4 lines of G-code that tell the coordinate system where to go, the end effector of the CNC, where it needs to go to create that square. So that's my involvement in Linux CNC. I was involved a little bit when I was writing PHP back in the day, and I created an Apache server. I believe I did that in Linux. I can't remember. Maybe it was no, it was probably in Linux. And so I have that kind of involvement, but not too much. But I love the environment. I love Linux. I wish that I was doing more with it. Apparently, most of the internet is under the Linux platform. So it is worthwhile to learn. I love the varying experimental types of UI you have with Linux, because it's such a broad and open type environment, and there's so many distros and things that I actually do like, and I wish I was doing more with it. I'll probably create a virtual machine with it and play with it more in the future.
Yeah, I usually always use Linux headless, so no GUI. For work, I use a GUI, but it's Windows. But I mean, I've got websites hosted in remote cities, and I go in via SSH and FTP and that sort of. I never see a desktop on Linux. But I hope that answers your question, No Spam, because here's a follow-up compliment from No Spam. Patrick, thank you for being so real. You are a great autodidact.
Thank you. Thank you.
For those of you watching this on Elektor TV, I see that Patrick is making one of our colleagues jealous. Looks like Patrick has an awesome electronics workspace.
Well, actually, yeah, the electronic side is just this, actually. This is all I use in electronics is the bare chip. There's a little tiny thing that you can put into this part of your finger, and that is really it. And then something to flash the microcontroller with. And this microcontroller, just because it's an SMD, it's a surface mount device, I needed to create something that would be able to plug into some breadboards, so I can add my own electronics around it.
And what are you flashing with that? Is that red thing? Is it a USB to UART?
The red thing here is the it's ST. It's a Chinese version of the ST Link V2, and I'm using a Chinese version because I want people to be able to get into this this thing. And I believe I feel kind of bad using a Chinese version of something that's flashing it, but I have been spreading the word of ST Micro in so many ways. I don't have any more qualms about that, actually.
Awesome. We've got 12 minutes left. Let's try and motor through these. H. Cruz says, how can I leverage the ARM STM32 Microcontroller Platform to design an innovative CNC controller with real-time motion control, precise stepper motor handling, and efficient user interface integration?
I would start with understanding how to parse G-code. I kind of would start there. If you want to create something that is sort of standalone and that you can just enter the G-code right into the microcontroller in its flash or whatever other memory that you may have aside from the microcontroller, I would start with learning how to parse those types of G-code, learn the G-code, learn how to parse it, like parsing anything in C, and then using that to determine what pulses you need to deliver according to the mechanical system that you have and the way that the drivers are set, because you can set a number of varying microsteps per step. So you can have very fine microsteps. And what you can do is you can parse those things out, learn how to create the acceleration curve, the velocity, and then the deceleration curve. And then you have your, after you've parsed it, you can deliver those pulses, because it's all it is. It's just pulses. It has nothing to do with like PID control or anything like that. The drivers that you have with CNC machines are generally going to accept step and direction pulses, no matter if it's a servo or if it's a stepper motor, because the servos the servo have drivers. They'll receive the step pulses, even though it's not a stepper motor. And then it converts that into a PID control, which is sort of closed loop control. So I would start there, just learning G-code and learning how to parse G-code, and then thinking about how distances would translate into a acceleration, velocity, and deceleration curve. That's it. See, very simple stuff.
Yeah, judging by the question, that could be a book, H. Cruz, but at least you have a starting point now.
There you go.
And Hector says that trial and error is good. We agree.
Absolutely. I'm a fan.
Sometimes you don't see the errors in people's publications, which is to the point that we were making earlier. Show the mistakes.
And people don't see them. Yeah.
People will have the same mistakes, so they'll be thankful that, they're not alone in that. Nothing worse than reading a slick tutorial and you type the command and it's supposed to do X and you just see a bunch of red text flash up. that's not what you said would happen.
Right, right. Yeah, and there's another. I've been re-uploading a lot of my videos to YouTube because they are now dubbed in different languages. So you'll see a lot of the stuff that in my I'm uploading about maybe 2 or 3 videos per day to try to catch up with all the videos that I have in my archives. And there are questions that I get in, like I have one that's called "I bricked my microcontroller," and I talk about one little tiny aspect of bricking it, and then I get a lot of comments on other things that could have occurred or what I should have done. Or so if I had that in a live stream, I would have gotten all of those comments then, and I would have been able to um, do a lot of different like experiments and showing what results with what you do in trying to unbrick it, or what I should have done in the beginning before I bricked my. It was kind of a soft brick. It wasn't really a hard brick. I'm able to use the microcontroller, but those kinds of things people are afraid of. That's the dark area that people are afraid of when going into this. Like, what if something happens? First of all, these chips are like, a couple bucks, so you're not going to lose that much money out of it. But they are afraid of the unknown, and that's where I think it's so important to put this stuff on live stream, to be able to show all of this stuff. Like starting from scratch, and like, what happens when I have an update in my IDE? What happens? Is it going to break my IDE? So that's happened on the live stream. It hasn't broken it, but it's those things that people just don't understand, and they can get that clarification through this type of stream, and they can ask the questions.
Yeah. Comment from Don, not a question. I would like to try to take advantage of STM32's real-time power, M4-/M7 cores, PWM timers, and ADCs to handle stepper motors and sensor feedback with precision. FreeRTOS could manage motion profiling. And he also says UART SPI or CAN for peripherals, and add a touchscreen or PC interface for a CNC setup. So not really a question, but a comment. Do you have a comment on the comment?
Absolutely. If you're just starting out and wanting to leverage this kind of power, I would also, that's really good to go there. I haven't gone that powerful yet, but I am looking forward to the N6 STM32 chips. The N6 is their new AI side of things. Now it actually has I believe it has a GPU on chip, and it can do amazing things with image detection and stuff like that. I watched their summit, and I'm really excited. And I was in that chat in the live stream saying, please give me a development board. I want to try this out, and I want to put it on live stream so I can inform other people about it and experiment with it and see what happens. I want to play with that one. And that's the power that I want. I want to get into the AI side right now and just like learn that whole new technology.
Yeah, I saw a bit about that chip. I believe it had real-time H.264 encoding on board, which is unusual for a microcontroller. So I was pretty impressed with that.
Yeah, another thing with the communication protocols he's talking about, most of the STM32 chips will handle all of that. I believe the one that I'm using doesn't handle CAN, and I want to get into that in some of my live streams. A lot of people have expressed interest in that. So whatever you actually learn, it doesn't really matter what chip you learn. You're going to learn those features no matter what chip you get, even if it's an M0, you're going to learn all of that. The free RTOS is one thing that I haven't gotten into, and you may need those more powerful chips to be able to get into that sort of thing.
Okay, and I thought that might be a USB to UART, but that you had. But question from Nullfile is going back to the picture on the breadboard. Is it a USB to UART? No, I believe it's not. It's actually a programmer.
This is just a programmer. It is connected to the SDW system of the microcontroller. So it's just, there is the power, which is 3.3 volts and ground. And then you have a clock and then an I/O. That's all that's here, which is very similar to UART, but this is, I believe it's a proprietary communication protocol. I don't actually know. I do remember the AVR used and the SPI communication protocol, and so that was the way they did their flashing. Not really sure what the protocol is, but you can use this single line for doing debugging and all, and monitoring of variables and things like that also, which I show in my live streams, which is really cool to see real-time variable monitoring on a microcontroller. It's really fun to play with that for sure.
Yeah, something I dreamed of back in the last century. Peter says, rather than using a knockoff Chinese ST-Link clone, any serial wire debug programmer should work, for example, Pico Probe. Not sure about that. What do you say?
Yeah, I don't know offhand myself. I'm not really sure what works other than this, because this is what I started with, and I am always open to experimenting with other things. So if anybody expresses interest in my live streams, if they want me to try something, I will. If it's not cost prohibitive, I will definitely give it a try and see if I can at least figure it out. But yeah, I'm sure that would probably work.
Well, that's great. And another comment here is from Hector again. STM32N6 looks amazing. Yeah, and if I look a bit distracted, it's because I'm finding the article that we published just on December 11th, which
it's very new. Yeah.
Yeah.
They use a whole suite of software too. Like it's not the Cube MX. I believe that you can still use that, but they have this thing called the Cube AI now. And I want to see what that suite of software can do. And also they're partnering with Qualcomm, I think. Who are they partnering? I think they're partnering with one of those companies. I think it's Qualcomm. But they're also partnering with another company that creates a development platform for this chip. And you have high level stuff that you can do object detection and do other AI type of black box. I think it's inference more than it is training, but I'm not really sure. It would be really cool to see if we could also implement training in sort of a small way into that as well.
There's a lot going on in this diagram, but I was intrigued by the bottom left here, the graphics, the camera pipeline, and of course the H.264 encoder. Fascinating stuff for a little microcontroller.
Yeah,
but
they put a lot of stuff in there, and it's a little tiny BGA.
Yeah, that's crazy. So that's it for. There's the link if anyone wants to read that article. And there was another question, a reminder of the code words. So I'll just put that up again. It's BuildYourCNC for the simple reason that that is the name of Patrick's Daniel's page. I mean, on YouTube, on social media, it's buildyourcnc.com. So that is our code word for today. And there's the URL to enter. So good luck with that. And speaking of good luck, it looks like we've got about 10 seconds left of our scheduled hour. So I hope we didn't miss too much in the comments. No. Got one to read, but I'm not going to read it out loud due to time. But thank you for that, Ken. And Patrick, I would just like to thank you for taking this hour to spend with us on the show. As I said, there's a lot of overlap, very interesting for our audience. So thanks for joining us.
It was an absolute honor. Thank you for having me.
Well, you're one of those guests where 1 hour wasn't enough, so maybe we'll hit you up in a few months and you can join us again. But,
anytime, anytime, and I hope to see you in the live stream as well, and everybody else if you guys want to see me make blunders.
Yeah, so I will join you in exactly 2 hours. So it's 6 p.m. here. It'll be 8 p.m. for me, 1 p.m. Eastern, 7 p.m. in Central Europe. But we've got people from right across the world. So should I just say 1600 UTC for people all around the world? Patrick goes live at that time. So I'll pop in and say hi and join us then. And then you get another hour or more of Patrick. So we were cut short here. We have to move on. Thanks for joining us, Patrick, and thanks to everyone in the chat for joining us from all around the world. I see a lot of you, and it's a very interesting chat and a lot of interesting questions. So thanks for joining us. And to those who enter the competition, and I would advise you to, because it's a great prize. Good luck to all of you, which is unfair because I'm giving equal luck to everyone, but I hope a deserving person wins it. Thanks again, Patrick. Thanks to everyone for joining us, and good night from here in Johannesburg.
Bye-bye.